Hello guys, welcome to another video from Computation channel. In this video, we're gonna continue our playlist in interview coding, and actually we're gonna solve another question from LeetCode website. And actually this question that we call it merge to sorted list. This is one of the most famous question that you may see in your interview, and actually the origin of this question was from Microsoft company that somehow people see this question in their interview, and after that they add this question to LeetCode. And in this video we're gonna solve this question with a new method for you and explain it fully to you to become master in this question. And yes, that's it guys, let's solve it together. Okay guys, as you can see here, this is the question that we have: merged two sorted lists. You are given the head of two sorted linked lists. So based on this part, we have two linked lists that we call them list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of merged linked list. So all we have to do is that we have to somehow merge these two linked lists together, and after that we have to return the head of our merged linked list here. So this is the example that we have here. We have two actually linked lists here, that the first one contains 1, 2, and 4, and after that we have 1, 3, and 4. So first we have two header here. One is in the head of list 1 and another is on top of head of list 2 here. We have 1 and 1, so it doesn't matter here, they are both are equal together, so we can add one of them to our final linked list. And somehow, for example, if we have a pointer here, we can move this pointer to next element that we have here, that is, we call it 2 here. And after that we must compare these two new pointer here, that's are 1 and 2. We compare this and we know that 1 is smaller, so we move this pointer here to 3, and after that we continue this actually loop here until we reach our final actually answer here. So we can see these two example here. Example number 2 is that if we don't have any linked list, so our final answer doesn't have any headers, so we have to actually somehow return the non-value for this question here. And for final actually example here, we can have an example that one of our linked lists don't have any element in it, and another may have some element in it, like this one here. List 1 is empty and list 2 only contains 0. So let me actually here explain the solution that we want to use here. The method that we can use here, that we call it somehow the dummy, or this is how we call this method here, the dummy, or we can explain it with some other actual names on it. The method is something like that. We define a new actually linked list header. We know that linked lists contain two things in it. One is a pointer to our next actually linked list, node of our linked list, like this, and this one contains the value of our node here. So for every linked list we have a pointer to next node, and we have actually somehow a space in it that will keep the value of our node here. So this is the linked list. All we have to do is that we made a dummy linked list here, like this, that the value of this dummy linked list is none. We don't have anything in the element, and all we have to do is that we actually point our pointer to the first, or better I said, the smallest element that we have into linked list, and after that we start to merge these two linked lists together. For example, if we have this example here, 1 and like this, 2, and after that like this, 3, and another linked list is like this one here. Actually we some have 2 and after that 4, yes, like this. First, we define a new node that we call it dummy, like this one here, actually, like this one. So, and after that, we add the smallest element in the two to linked list that we have here. So the smallest one is the one that is here. So we will add this node here as the next pointer to our linked list, so it will contain one. And after that, we move this counter, or better I say pointer, to next node here, and this will stay here. After that, we will compare 2 and 2, and we know that these are equal, so we can actually add one of them. It doesn't matter for us, like this 2. We will actually move this pointer here to this one, and after that 2 and 4, we know that we have to add 2, like this actually, and after that between 3 and 4 we have to add 3, and after that we have to add 4, like this. So this is the basic solution that we have here. The time complexity of this question will be O of n, actually, or better I say the big O of length of list 1 plus length of list 2. Let me erase it here, list 2, yes, like this, because we will iterate over our 2 linked lists and merge them together. So our time complexity is the plus of length of list 1 and list 2, and our space complexity is from order of actually 1, because all that we do here was that we define a new node that we call it dummy, or I don't know, new node or something like this, and after that we start to iterate over our 2 linked lists. So let's go for coding here. In the coding first, we have to define our new node or nodey node, something like this. So our new node is an object from the list node class that we have here. So it will become like this. Yes. And after that, we must define a new variable that we call it tail. That in the first part, it is equal to new node. And after that, we must actually move this tail over our 2 linked lists until we reach the final part. And in the final, all we have to do is that we have to call new node actually dot next that contain the merge of our 2 linked lists. So we will start like this, yes, and we write this code that until we have both list 1 and list 2, actually list 1 and list 2, we will compare these two, actually the value of our 2 nodes in these 2 linked lists together. So if actually list 1 dot val actually is lower than list 2 dot val, like this, or sorry, here list 2 dot val, all we have to do is that we must add the list 1 dot val because it is smaller than list 2 to our tail. So it will become like this. Tail is actually tail dot next is equal to the list 1, yes, and after that we must move our list 1 pointer to the next element. So list 1 is equal to list 1 dot next, yes, it will become like this. And in our else condition, we will move the pointer of list 2, so it will become like this. List 2 dot actually, or better I say tail dot next is equal to list 2, and after that the list 2 is equal to list 2 dot next, yes, it will become like this. And for equal condition, we will have this condition in this part in our else condition, because in this part the list 1 dot value is smaller than list2.var. In our else condition, we have the condition that list2.val is smaller or equal to list1.val. So we have this condition until we have two of our linked lists. But if we reach the end of one of our linked lists, what will happen there? Oh, and also in every part we have to move the pointer of our tail. So we will move our pointer to tail.next. Our tail in every part must be in end of our linked list. To we add another element to it and move this tail to the next element. So it will become like this. And if we reach the end of one of our linked lists, what will happen? For example, let me show you. For example, if we reach the end of our linked list here, yes, we reach here and we have this part and add another node here, 5, and yes, like this. When we reach the last element of one of our linked lists, all we have to do is that we have to add all of nodes of other linked lists to our final and merge linked list, because we know that we have two sorted linked lists. So if we reach end of one of our linked lists, the other linked list is sorted. So all we have to do is that we have to add the pointer of another linked list to end of our final, or better I say, merged linked list. So here, if we reach the end of list 2, all we have to do is that we have to add tail, and tail.next will become list 1. And else, if we reach the end of the list 1 here, we have to add list 2 to end of our linked list. So it will become like this, yes. And finally, we have to return new node dot next, because we know that our new node element is actually the value of our new node is equal to none, and we have to start after this one. So let's actually try this code here. And yes, we accept and actually pass all of the test cases, and after that we have to submit this code. And yes, as you can see, we beat 100% of actually other codes, and in the space complexity, actually this one was very optimal and optimized for this question that we have here. And yes, this is the solution for the question of merge to sorted list here that I show you. I hope you guys enjoyed this video and learned a lot of useful things from this video, and hope you guys see this question in your interview, because now you can solve it with very optimized solution that I show you here. If you like it, you can like this video and subscribe to my channel, and if you have any idea or opinion that can help me and actually grow my channel, you can leave them in the comments part. And yes, that's it guys. Have a nice day guys. Goodbye.